Well, if we want to think about minimizing mean squares within, we should really think about where it comes from. So I'm going to ask you to guess an answer to this question to see if you really understand mean squares within. And again, I'd like you to pause the video and write down your answer and see how you do. So, in thinking about mean squares within, here's what I want you to realize. These deviations, right, within groups, they are what makes up mean squares within, right? If you think about one group on its own, and you think about the differences between the people in the group, right? The within group differences, right? Think about whether these people were treated any differently. The answer is they were not. If you're a good experimenter, you keep everything completely identical across the entire study except one thing, and that's your independent variable, right? So that means that these people all got the same set of instructions, environment, cola that they're drinking, the same experimenter, the same level of heat, noise, hunger, etc. Right? You're going to keep as many things as you can completely identical between these people. So if you've succeeded at that, if you've designed it well and you have good control over your environment, why would people get different scores? They all got the same instructions, same experimenter, same environment. They all drank cola, the same kind of cola. So if you treated them identically, now I want you to write this answer, pause it, write what you think the answer is, and then unpause it. Could these differences between the people who are all in the same group, these within group differences, could they have come from being treated differently? Yes or no? So pause it and say within group differences either could or could not come from the fact that people were treated differently within the group. Now again, we're assuming you've done your experiment well. Okay, so when you paused it, I hope that you wrote that these differences could not have come from people within the same group being treated differently. If you thought they could have, let me ask you this. What exactly do you think happened in the way these people were treated that was different between these people within the same group, that was different for one of them or the other? And the answer should be, I can't think of anything. You shouldn't be able to think of anything because what did we just say if you were listening carefully? There are no differences in how you treat people within the same group. You treat them all completely the same in every conceivable way. Why then don't they all have the same score for how much they liked what they drank? They all drank the same thing. They all got the same instructions, etc. Well, let's think about this. If there is variability, that is differences within the group, right? It comes from anything but the treatment. And what might be tugging or pulling on scores or moving scores around, causing variability other than the treatment? It is error. It's just unexplained things happening. It's chaos, noise, random things. Let me give you some examples. So, physiology, having different physical bodies. Maybe monkeys have the taste buds that love sweet stuff, so they would rate a cola, this guy rated a cola a 10 because he's a monkey. Aliens don't have taste buds that detect anything earthly, so he rated cola a 0. This guy has his taste buds influenced by the fact that he's just been drinking, he's a pirate, he's been drinking rum on a pirate ship for decades, and he gave it a 2 because he can't even taste the sweet anymore, whatever. Their physiology differs, and that can move their scores around. Whims. Maybe this dude, the alien, just thought he should put a 0 because he thinks circles are pretty and he's learning about earth shapes. Who knows? All right. Personality. Maybe the pirate's a cranky old dude and he would never give anything more than a 2 even though he loved the cola. Personality can make differences happen between scores. History. If someone just came in from eating a piece of cake, maybe the cola will taste a little less sweet and get a lower score, for example. Right? Demand characteristics, well, you shouldn't have any of those because you won't be telling people to do different things. You'll be telling them to do exactly the same thing. Sip this drink, write on a 0 to 10 scale how much you like it, etc. So if we think about where mean squares within comes from, and we know we want to minimize mean squares within, let's think about a hypothetical scenario where we could minimize mean squares within. Here's what we'd like to do, but we can't. We would like to replace everyone in our study with a clone of himself. So this group would be all one guy, this would be all one guy, this would be all one guy. At the extreme level, you just give the same guy cola 3 times and rate it, right? Same guy grapefruit juice 3 times, same guy cod liver oil 3 times. Now obviously there would be a problem with this and we'd never do it, right? Now, it would cut our mean squares within because he'd have, everybody we're taking observations on would have identical physiology, personality, history, so the only thing operating might be whims or little random firings in their brain, right? Well, okay, we can't really do this. It would be ridiculous, right? Obviously, if we do a study on one person and we're only studying one person and we just take a bunch of observations on one person, anybody trying to rip our study apart is going to say, well, this doesn't apply to people at large. It applies to this guy from Mars. Not really very useful. However, here's what we can do. We can recycle our subjects. And that's what we do in a within subjects design. We get rid of some of the variability that comes from having a lot of different people. Now, we take these guys and give them all cola and ask them to rate it. We take a rating. Then we give them all grapefruit juice and ask them to rate it. Then we give them all cod liver oil and ask them to rate it. Okay, let's talk problems, because if you're a good methodological thinker, you hopefully are thinking of problems right now. If this guy has cola and immediately has grapefruit juice, he's going to go, wow, that's sour, after having cola in his mouth. This is a carryover effect, and it could be a problem. There are some drawbacks to a repeated measures design. So if you were doing a repeated measures design where you repeatedly reuse or recycle the same person, the same subject, right? And you take repeated measurements, that's why it's called a repeated measures design, also known as a within subjects design. Pause this now and write that down. Repeated measures, within subjects, everybody is in each group. People get more than one treatment. Okay, so you can imagine there would be a carryover effect, yes? That could be a bad thing. So you might have to cleanse the palate in between with some water, right? You might let time go by in between and have people do all the same activity or something. Anyway, a carryover effect is a problem with this design, but you can deal with it in different ways. Okay. The other problem is, that you may be thinking of, is, wait a minute, we had all these people who were willing to participate in our study and we just threw them away? What did we learn in the lecture about power? That the bigger the n, the more statistical power, and the more likely we are to get f obtained where we want it, to have it be big. Isn't that true with this design? If you're thinking that, good insight. We probably actually wouldn't throw these people away. What we would do is, we'd just put them in every treatment, right? So you would wind up giving everybody cola, including the frog and the zebra and the lion, right? Okay, so in reality, we wouldn't throw out subjects unnecessarily because we like having lots of subjects. But here's the thing. In many experiments, we can't get a lot of subjects. So if that's your situation, here's a good thing about this within subjects repeated measures design. If you can recycle or reuse your same subjects, you can get the same amount of data with fewer subjects. So if you have to, you can use fewer subjects and have a shot at getting a finding. So that's a good thing. You can You wouldn't unless you have to. You always want as many subjects as you can get, right? Okay. But you can use fewer subjects, and that's a good thing, because sometimes subjects are rare, especially if you're laying out a lot of money, or they're hard to get, or it's a rare disease you're studying, whatever.